In this lesson, we've used all that we've learned about angles and similar figures to find missing parts in a figure. We also investigated the angles in a polygon. Now we've seen that if we have a triangle, all the angles in a triangle must add up to how much? Do you remember? 180. So if that's 40 and 30, which is 70. This angle is going to have to be 110 degrees. All these angles have to add up to 180. All right? So we know that the sum of the interior angles in a triangle add up to 180. Well, we were able to investigate any other polygon like this pentagon here. And if we pick a vertex and we draw in the diagonals going from that vertex, just one vertex, well, then we know that this is 180 degrees in this triangle, 180 degrees in this triangle, and 180 degrees in this triangle. So there's 3 times 180 degrees, which makes a pentagon have 540 degrees total. Well, we generalized that, and we found a formula for the sum of the interior angles of the polygon. And we can say the interior angles of that polygon add up to, let's say T for total angles, all right, or total degrees if you want, equals n minus 2 times 180. If n is the number of sides, then n minus 2 times 180 will give us the degrees in that polygon, all right? So this theorem is true for any convex or concave polygons. By the way, convex means it looks, something like this. Concave, just to remind you here. So concave means we have a polygon that kind of caves in. So this is concave. Okay, so yeah. All right. So we can find missing sides and angles in a complex drawing when we look for structure in that diagram. Some tools that we use today was we use the Pythagorean theorem, which is very important. Now remember that the Pythagorean theorem only works for right triangles. So this has to be a right triangle. And we got 3 sides, A, B, and C. C is the hypotenuse, the longest side. And we know they are related by the equation a squared plus b squared equals c squared. So we use that. We also use the side splitter. So the side splitter theorem is when we have similar triangles made by parallel lines. So if we have a triangle and we have a line that's parallel to one of the sides, let's make that parallel. There we go. If those are parallel and this side is broken up into lengths of, let's say, A, B, and this is C and D, well then A over B equals C over D. All right, so it makes a nice proportion. That happens when we have parallel lines. So we use that as well as using this angle sum theorem. All right, so the total angles equals n minus 2 times 180. All right. Okay, so here's a vocabulary for you. Concave, like we just said, it means that at least one of the internal angles is more than 180. Okay, it's possible to find 2 points of the polygon that when they're connected, there's a line segment outside. That's another way to say that. All right, so if we try to connect these two, there'll be a line segment outside. Okay. Convex means that no internal angle measures more than 180. Looks like we have some angles that didn't print there. All right. If any 2 points are connected, then all the diagonals are inside the polygon. So, all right. Great. Well, there's kind of recap of that. All right. Here, let me draw a concave polygon, or convex. Sorry. Convex just is kind of normal. So it's not caved in. That's convex. Great. Well, let's see how we can apply a little bit of this. So let's see how this angle sum theorem works that we just talked about. Well, we know the angles in a triangle add up to 180. So we can make a little equation. 70 plus 30 plus x equals 180. Good idea to use your algebra here. Add up that 70 and 30. And then let's solve this using our algebra. We could probably write this out in a couple other ways, but we really want to get good at using our algebra. All right, so make an algebra equation because this will always work nicely. Well, we have a quadrilateral here. And, well, we got to ask ourselves, well, what do all the angles add up to? Well, we have 70 plus 110 plus 80 plus y. That has to equal a total. Well, in order to find out what that is, let's remember our theorem. So the total angles, or the total of the angles in the polygon, is n minus 2 times 180. So this is n in this case is 4 sides, and its number of sides, 4 minus 2 times 180. All right, let's use our algebra to solve this up. Well, this is 110 plus 70, which is 180, plus 80 is 260. 260 plus y. All right, now this is 4 minus 2, which is 2. 2 times 180 is 360. So that's going to be 360. Let's subtract 260 from both sides, and we have our answer. Y is 100 degrees. Okay? That's all there is to it. Let's try a pentagon here. All right, so we have a pentagon, 5 sides. Let's go ahead and write it out. We've got 100 plus 90 plus 96 plus z plus z. All right, and there's 5 sides, so our formula once again is n minus 2 times 180. So we have 5 minus 2 times 180, and that gives us 286 plus, and z plus z is 2z. Watch out, don't let your z's look like a 2. I like to put that line there just for that purpose. And 5 minus 2 is 3 times 180. 3 times 180 is going to be 540 degrees. So we're getting close. Let's use our algebra. Let's subtract first. 286. All right, so if we subtract 286 here, we're going to get 2z on this side. That's going to go away. And we end up with, well, let's see. 540 minus 200 is 340. And minus 86, well, let's see. How far is it from 340 to 86? 340 and 86. Okay, minus 86. Well, that's like taking away 40 and 46, which I think comes out to be 254. Sounds good to me. Can double check there. 54 plus 86 is 140. And 200 makes 540. Cool. Found it. Good deal. Divide by 2, divide by 2. And we have our answer. Our answer, x equals half of 254. Half of 200 is 100. Half of 54 is 27. There you have it. Actually, it's not an x, it's a z. We should keep the right variable here. All right. Well, does that make sense? I hope so. We got all the angles, including the variables for the ones that we don't know. And that has to add up to n minus 2 times 180. N, again, is the number of sides. This guy has 5 sides. All right. Well, here's some review practice ones in this retrieval here. You might want to pause this and try this out for some good practice. All right. Let's go ahead and work on it together. We're going to use the Pythagorean theorem here, find the missing lengths. And then we're going to decide if they're similar or not, all right? So let's find some missing lengths. So here we've got a missing side. Maybe I'll call that x. Maybe I'll call this y. We need to use the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals c squared. It's a good idea to always start with an equation that looks like that formula when you're working with right triangles and finding missing sides. Okay, because if you start somewhere else, well, you're kind of starting somewhere that's not normal, not commonly acceptable. So anyway, start with the equation. Use your algebra. We have 5 squared. Now, notice this. The C is the hypotenuse. The hypotenuse is the longest side. Okay. The hypotenuse does not make the right angle. So we got the hypotenuse. That's this one here. And these other two sides, these are the legs. There's 2 legs, just like people have 2 legs. All right. A right triangle has 2 legs. All right. So the 2 legs are 5, and we might say x squared. All right. And so let's use our algebra. 25 plus x squared. And 13 squared is 169. Let's subtract 25 from both sides. And when we subtract, we get x squared equals 144. And square rooting that, the opposite of squaring is square root. So we square root, and x equals 12. So this one equals 12. All right, now, if we have a right triangle, we've got 9, 12, and y. So let's try that out. So we've got 9 squared plus 12 squared equals y squared. And this is 81, and 12 times 12 is 144. Add those together, 245. All right. And if we square root that, the opposite of squaring is square root. We're going to get the square root of 245, which is 15.65. Now the question is, are they similar? Well, we've got 3 sides. So let's find, we've got some answer blanks here. We got 12 for that missing side there and 15.65. So similar, we're going to need to check to see if side is true here, all right? So if they are proportional. So if we take these 2 sides, take any pair, any 2 corresponding pairs. And let's say we take this 5 here over 12. So we have 5 over 12. So that's like the small leg over the long leg. If we take the small leg here over the long leg here, we get 9 over 12. Are those 2 things equal to each other? Is 5/12 the same as 9/12? No. So they're not in the same proportion. So no, these are not similar because the sides are not proportional. Okay. To be similar, the sides have to be proportional and the angles have to be congruent. Right? Well, a little bit of algebra review here. Again, if you haven't done so and you want to, you pause and see if you can do this. Let's give it a try, see what we can remember. Let's get all the x's on one side by getting rid of that 3x. You can do this in a couple different orders. 5x minus 3x is 2x. These cancel. Now we got all the x's on the right. Let's get the constants out of here. So let's go ahead and add 5. And we've got 12 equals 2x. And last but not least, we want to divide. So let's divide both sides by 2. And we end up with 6 equals x, or x equals 6. All right. Number 10. Well, number 10, we need to simplify first. So let's distribute this 5 out here. We have 5x plus 15. And let's distribute this 7 out, so equals 7x plus 7. Now it looks like number 9. So what we need to do is we need to get all the x's to one side. You choose. I'm going to go ahead and subtract the 5x because that'll keep it positive. If I went the other way around, it'd be a negative. 5 minus 7 is negative. But that's good. So 2x plus 7. Sorry about that. Now we've got to get the x's by themselves. So let's go ahead and subtract that 7 from both sides. And 2x equals 15 minus 7 is 8. The opposite of multiplying is dividing, so let's divide. So x equals 4. There we have it. And number 11 here, we need to, it's a proportion, so we need to cross multiply. So let's go ahead and cross multiply. We've got 3 times 84. And we've got 12 times x plus 7. Make sure you hit that x plus 7 in parentheses. That's super important. So if we multiply this out, we got 3 times 84. That's 240. But plus 3 times 4 is just 12, so 352. And let's distribute here. We get 12x plus 7 times 12, which is 84. Now it looks a lot like number 1 or 9, I guess it was. So linear equation here, subtract 84. And let's see, 25 minus 8 is 17, so it'll be 172. Maybe better yet, let's subtract 4. That'll give us 248. And 240 minus 80 is 168. Double check that should work. 8 plus 2, 8 plus 4 is 12. Yeah, I like it. Equals 12x. Let's divide by 12. Let's divide by 12. Well, this is 12 goes into 120 10 times. If you take 120 away from there, you have 48. 48 is 4 12s. So this is 14. And 12x divided by 12 is x. All right. So there's some review for you on solving equations. If it's a proportion, we cross multiply. We need to distribute here before we add and subtract. And just remember, we want to get all the x's on one side, all the constants on the other. Okay. All right. Well, hope that gets you all caught up there if you were missing or misunderstanding. So hopefully that helps. Thanks for joining us.